This video is for GCF, Greatest Common Factor review, and also some practice. So just to remind you, when finding the greatest common factor, GCF, we're going to make factor trees, and we need to boil every composite number down to a list of primes. So this is the list of prime numbers from 1 to 100. This would be a good screenshot to come back to when making your factor tree, so you know if you can break down a number even further or not. So all the highlighted numbers are prime because they have only two factors, which is themselves and 1. If you get to any of the other numbers, they are composite and they can be broken down even further. Alright, so let's remind you of a factor tree. So if I have the number 24, I need to pick any two numbers that multiply into 24. And I'm going to pick 12 and 2. When I get a prime number, any number from this list, I'm going to circle it, showing that it's prime and it can't go any further. The numbers that are not prime, like 12, can still be broken down further. 6 and 2, and 3 and 2. And then we would say that 24's prime factorization is 2 times 2 times 2 times 3. And you can also write this as 2 to the third times 3. So that is the prime factorization for 24. You're breaking it down to all prime numbers. Why don't you go ahead and try to create a factor tree for the number 27. Pause the video, hit play when you're ready. Alright, so 27 breaks into 9 times 3 and 3 times 3, which is 3 times 3 times 3, or 3 cubed. Alright, you ready for one more? Let's try 54. Again, pause if you need time. Alright, so 54, I'm going to start with 6 and 9. The good thing about factor trees is you can start with any two numbers and you should still wind up with the same answers. Neither of those are prime. So we go to 2 and 3 and 3 and 3. So you have 2 times 3 to the third power. Alright, so now let's get into what you're going to do next, which is a handout or a couple handouts that look like this. So at the top you have some numbers, and we're going to start with E and do this example, and I'll show you how the bottom works. So you're going to break this down into the factor tree, which 66 is 6 times 11. 11 is prime. 2 times 3. 2 and 3 are prime. So your prime factorization is 2 times 3 times 11. Well, you're going to come down to the bottom, and you're going to find E, because that's the one we just did, and you're going to color in, shade in, the prime factorization. So we had 2 times 3 times 11, so it would be 1, 2, 2 times 3 times 11. And that's it. Go ahead and try D, and then I'll walk you through the answer. Alright, if you need more time, pause the video for it. So this one, I'm going to start with 108 times 10, which is 2 and 5. 108 is going to be 12 times 9, which is 3 and 3, which is 3 times 4. And you kind of can't see this, but 4, let me change my color, is going to be 2 times 2. So we have 3 times 2 times 2 times 3 times 3 times 2 times 5. Whew, alright, so how many 2's is that? This is why it's easiest to write it as exponential notation. So we have 2, 1, 2, 1, 2, 3 to the third power times 3, 1, 2, 3 to the third power times 5. And then we can go down to D, and we're going to get 2 to the third power, 3 to the third power, and 5. Alright, so the rest of the sheets, there are some larger numbers and there are some smaller numbers. So do what you can, and we'll check your answers later. Good luck.